Hello everybody, welcome into another lesson. So today we are going to talk about multiplying binomials with radicals in them. Here is the first example. You have the quantity of 2 plus the square root of 3 times the quantity of 2 minus the square root of 3. Well, if we remember here, when you have the same numbers, but you have 1 plus the number and then 1 minus the number, if they're the same numbers, you get a difference of 2 squares. It would be no different than if we did something like x plus y times x minus y. Right? You have the same variables, one's plus, one's minus. You would end up getting x squared minus y squared. That's what you would end up getting. And then your middle terms would cancel out, your xy terms would cancel out. Well, the same thing's going to happen here with these square roots. So if you take 2 times 2, you'll get 4. Alright, your middle terms with the square roots will cancel out, but you have positive square root of 3 times negative square root of 3. That would turn into minus 3. And the answer you should get is positive 1. So you end up getting 1 as your answer. And I got more examples here. Let's see, we have 4 plus the square root of 11 times the quantity of 4 minus the square root of 11. Well, again, we have the same numbers, one's plus, one's minus. This would end up being a difference of 2 squares. You would treat it like a difference of 2 squares. So 4 times 4, that's 16. And then positive square root of 11 times negative square root of 11, that would give you negative 11. So you have 16 minus 11. The answer to this would just end up being 5. And so you get 5 for your answer. Alright, let's see. We have the square root of 15 plus 6 times the square root of 15 minus 6. Alright, so what this is going to end up being here, again, it looks like another difference of 2 squares. So square root of 15 times square root of 15, that's 15. And then positive 6 times negative 6, well, that's negative 36. So you'll end up getting 15 minus 36, which should give you an answer of negative 21. So negative 21 would be the answer you would get for this. All right, let's see. We have the square root of 19 minus 9 times the square root of 19 plus 9. So once again, we have the same numbers. Well, square root of 19 is 19. When you multiply the square root of 19 times the square root of 19, then negative 9 times positive 9, that's negative 81. So you'd end up having 19 minus 81, which would end up being negative 62. So the answer to this problem would end up being negative 62. Let's see here. How about this one? We have the square root of 3 minus the square root of 2 times the square root of 3 plus the square root of 2. So both of these are square roots, but you still, one is minus the numbers, one is plus the numbers, so you have a difference of 2 squares. So square root of 3 times the square root of 3, that would just be 3. The negative square root of 2 times positive square root of 2, that would just give you negative 2. You end up getting 3 minus 2, which would give you 1. So the answer to this is 1. All right, one more simple one here. We have the square root of 15 minus the square root of 3 times the square root of 15 plus the square root of 3. So again, it looks like we have a difference of two squares. So square root of 15 times square root of 15, that'll give you 15. Then you got negative square root of 3 times positive square root of 3. That would give you negative 3. So you have 15 minus 3, which would give you 12. So the answer to this is going to be 12. All right, let's shift it a little bit here. This is a little bit different. So we have 2 plus the square root of 7. That quantity is raised to the second power. So now all of a sudden we have 2 plus the square root of 7 to the second power. If we recall, this is a binomial square. To deal with a binomial square, if we remember, we take the first term, which would be that 2 to the second power. So the first term to the second power, then you add 2 times the two terms multiplied together. So far you have 2 squared plus 2 times the square root of 7, plus then you'll take the last term to the second power, which would be the square root of 7 raised to the second power. Well, 2 to the second power is 4, plus then you have 2 times 2 square root of 7, which would give you 4 times the square root of 7. Plus you'll have square root of 7 to the second power. Well, square root to the second power cancels out the square root. You would have plus 7. Which, to simplify this further, 4 plus 7 is 11. Then you just have plus 4 times the square root of 7. So the answer you should get for this problem will be 11 plus 4 times the square root of 7. That's as much as we can simplify. 11 plus 4 times the square root of 7. Alright, this time we have 8 minus the square root of 6 raised to the second power. So 8 minus the square root of 6 raised to the second power, well, that's going to end up being, of course, take your first term to the second power. That would be 8 to the second power plus 2 times these two terms multiplied together. That would be 8 times negative square root of 6 plus your last term to the second power. That would be negative of the square root of 6 raised to the second power. So now 8 to the second power, well, that's 64. Then you have 2 times 8, which is 16, times negative square root of 6. You would get minus negative 6. You get minus 16 square root of 6. And then you have plus negative square root of 6 to the second power. That negative would turn positive since you're squaring it. Square root of 6 would just become 6. So to simplify this further, you would end up getting 70 minus 16 times the square root of 6. And that would be your answer. 70 minus 16 times the square root of 6 would end up being your answer for this. All right, let's see here. What if we had two times the square root of 2 minus 3 raised to the second power? So again, this is another binomial square. You're going to take the first term, that 2 times the square root of 2 to the second power, plus you'll end up taking 2 times these two terms multiplied together. So that would be 2 square root of 2 times negative 3. Then you would end up taking that negative 3 to the second power. You would add that. Well, alright, let's see, 2 to the second power is 4, so you'd have 4 times the square root of 2 squared. Well, 4 times 2, that's 8. You'd end up having 8. And then you have 2 times the square root of 2, that'd be 4 times the square root of 2, times negative 3, that'd be negative 12 times the square root of 2. So far you have 8 minus 12 times the square root of 2, excuse me. I don't know where I got square root of 3. That should be square root of 2. And then your negative 3 to the second power, that become positive 9. So now you have 8 minus 12 times the square root of 2 plus 9, which when you simplify this, you should end up getting 17 minus 12 times the square root of 2. And that would be your answer to this problem, would be 17 minus 12 times the square root of 2. Alright, last one like this. We have 4 times the square root of 10 plus 3 raised to the second power. So we got the quantity of 4 times the square root of 10 plus 3 raised to the second power. Well, we're going to take the first term, that 4 times the square root of 10, we're going to raise that to the second power. Plus we'll take 2 times these two terms multiplied together, so that'd be 2 times 4 times the square root of 10 times 3, and then you would take that 3 and raise it to the second power, which, okay, first term, 4 to the second power is 16 times the square root of 10 to the second power, which would be 10. You'd have 16 times 10, that would give you 160. Plus, then you have 2 times 4 times the square root of 10, that's 8 times the square root of 10, times 3, that'd be 24 times the square root of 10. Then plus you have 3 to the second power, which is 9. So when you simplify this, the answer you should get would end up being 169 plus 24 times the square root of 10. And that would be as far as you could get. It would be 169 plus 24 times the square root of 10. So if you remember how to deal with the difference of two squares, and you remember how to take a binomial to the second power, and then now we're about to do some FOIL ones. If you remember how to FOIL also, you'll be good with this. This won't be so bad. Alright, let's see here. Why don't we do this one? We have 4 times the square root of 3 minus 5 times 2 times the square root of 3 plus 3. So this time we don't have the same numbers. The only thing we can do is FOIL. We'll just have to do the good old-fashioned FOIL method. So FOIL, the first terms, that would be 4 times the square root of 3 times 2 times the square root of 3, plus you'll take your, so first an outer would be 3 times 4 times the square root of 3. Then inner, you would have negative 5 times 2 times the square root of 3. I'm going to have to write down lower. And then last, negative 5 times 3, so you'd have minus 5 times 3. Let's take all this here. Start with your first term. You have 4 times the square root of 3 times 2 times the square root of 3. Well, 4 times 2 is 8, right? Square root of 3 times the square root of 3 is 3, so 8 times 3, that would give you 24. You get 24 for your first term, plus 3 times 4 times the square root of 3, that would give you plus 12 times the square root of 3. Then you have negative 5 times 2 times the square root of 3, that'd be minus 10 times the square root of 3. And then you have minus 5 times 3, that would be minus 15. So now we can simplify this. 24 minus 15, that's going to be 9. And then 12 times the square root of 3 minus 10 times the square root of 3, that'd be positive 2 times the square root of 3. So the answer you should get for this would end up being 9 plus 2 times the square root of 3. That would be your answer. And I got some more foiling ones. Alright, let's see here. 6 times the square root of 2 plus 4 times 3 times the square root of 2 minus 5. So we got the quantity of 6 times the square root of 2 plus 4 times the quantity of 3 times the square root of 2 minus 5. Well, again, none of your numbers are the same. None of them are, so your only option now is to use FOIL. So let's see. We'll take the first ones here. 6 times the square root of 2 times 3 times the square root of 2. Okay, so we've done the first ones. Now plus the outer, so you'll have negative 5 times 6 times the square root of 2. Then plus the inner, which would be 4 times 3 times the square root of 2. Then the last, you'll have 4 times negative 5, so that would be plus 4 times negative 5. So yeah, these can get to be long. Alright, start with your first one. 6 times the square root of 2 times 3 times the square root of 2. Well, 6 times 3 is what? 18? Square root of 2 times square root of 2 is 2, so you have 18 times 2, that would be 36. Now, negative 5 times 6 times the square root of 2, that'd be minus 30 times the square root of 2. Then you have positive 4 times 3 times the square root of 2, that'd be 12 times the square root of 2. And then 4 times negative 5, that'd be minus 20. So now we can go ahead and simplify this. So 36 minus 20, that's going to give you 16. Then negative 30 times the square root of 2 plus 12 times the square root of 2, that would give you minus 18 times the square root of 2. And we can't reduce this any further, so the answer you should get for this would be 16 minus 18 times the square root of 2. Alright, let's do 2 more like this here. We're going to do 2 more like this. So then we have 2 times the square root of 5 minus 6 times the square root of 7. That quantity times 3 times the square root of 5 plus the square root of 7. So again, we have 2 binomials being multiplied, all with different numbers. We have the quantity of 2 times the square root of 5 minus 6 times the square root of 7. That quantity times 3 times the square root of 5 plus the square root of 7. So we're going to FOIL. Do your first terms, that 2 times the square root of 5 times the quantity of 3 times the square root of 5. So those are being multiplied together. Now you do your outer, so 2 times the square root of 5. You'll take plus 2 times the square root of 5 times the square root of 7. Now you'll do negative 6, so this will be plus negative 6 times the square root of 7 times 3 times the square root of 5. And then you'll do the last, so you'll do minus 6 times the square root of 7 times the square root of 7. Alright, so we have a fun one in store. So we have 2 times the square root of 5 times 3 times the square root of 5. So 2 times 3, that's 6. Square root of 5 times square root of 5, that's 5. So 6 times 5 would give you 30. So we have 30 for the first one. Plus we have 2 times the square root of 5 times the square root of 7. That would just give you 2 times the square root of 35. Then you have plus negative 6 times the square root of 7 times 3 times the square root of 5. Well, negative 6 times 3, that's negative 18. And then square root of 7 times square root of 5, that'd be times the square root of 35. And then last but not least, you have negative 6 times the square root of 7 times square root of 7. Well, square root of 7 times square root of 7 is 7, right? Then so you just take 7 times negative 6, you would end up getting minus 42. Now we can go through and simplify this. 30 minus 42, that's negative 12. Then 2 times the square root of 35 minus 18 times the square root of 35, that'd be minus 16 times the square root of 35. So the answer you should get for this one would be negative 12 minus 16 times the square root of 35. All right, last one here. So why don't we go with, let's see, 8, not the last problem, but the last problem like this. 8 times the square root of 6 minus 2 times the square root of 3, that quantity times 2 times the square root of 6 minus 3 times the square root of 3. Okay, so again, we have two binomials being multiplied. None of them are the same numbers, so we got to use FOIL. So for the first expression here, we'll do 8 times the square root of 6 times 2 times the square root of 6. So 8 times the square root of 6 times 2 times the square root of 6. Now let's see, we do the outer, which would be plus the quantity of 8 times the square root of 6 minus, or that'd be times negative 3 times the square root of 3, plus your inner would be negative 2 times the square root of 3 times 2 times the square root of 6. And then your last, you would end up taking plus negative 2 times the square root of 3 times negative 3 times the square root of 3. Alright, so we've done our foiling. Now we're ready to work on this. So first one, we have the quantity of 8 times the square root of 6 times 2 times the square root of 6. Well, 8 times 2 is what? 16? And then the square root of 6 times square root of 6 is 6. So we get 16 times 6, which would end up being 96. So we have 96 for this first one. Now you have 8 times the square root of 6 times negative 3 times the square root of 3. Well, 8 times negative 3, that's negative 24. Then square root of 6 times square root of 3, well, that's going to end up being square root of 18. And no, I'm not going to simplify the square root of 18 just yet. Not just yet. There's a reason for that. It's going to make it a lot simpler to add and subtract. Now we have plus negative 2 times the square root of 3 times 2 times the square root of 6. Well, negative 2 times 2, well, that's minus 4. Then square root of 3 times square root of 6, that's square root of 18. Now for the final part, we have negative 2 times square root of 3 times negative 3 times the square root of 3. Well, negative 2 times negative 3 becomes positive 6. So that would make this positive, and then square root of 3 times square root of 3 is 3. 6 times 3 is 18. All right, now we can start simplifying. So we have 96 plus 18. Well, that's going to end up being 114. So we have 114. Then negative 24 times the square root of 18 minus 4 times the square root of 18. That's going to be minus 28 times the square root of 18. Well, we're not done yet because the square root of 18 factors further, right? This could factor into, let's see, 114 minus 28 times the square root of 9 times the square root of 2, right? Well, then you would have 114 minus 28. Now your square root of 9, that's 3, so minus 28 times 3 times the square root of 2. Which, okay, now we have 114 minus 28 times 3. 28 times 3, that's going to be 84. So that would be minus 84 times the square root of 2. And that's all we can reduce this. You would end up getting 114 minus 84 times the square root of 2 as your answer. So yes, you always want to make sure these are in simplest form by reducing the square root as much as you can, factoring out perfect squares like we just did. So there's FOIL. Now we're going to shift gears slightly. We will shift gears slightly here. We're going to do some problems where we rationalize the denominator using what we've learned today. So, let me flip the page here. Say you have something like 1 over 1 plus the square root of 5. So you've been given 1 over 1 plus the square root of 5. Well, we have a square root in the denominator. We don't want that. We still have to rationalize the denominator. But how do you rationalize the denominator when you have a number plus or minus the square root? You're going to multiply it by what's called its conjugate. You multiply by what's called the conjugate. So there's the word conjugate. So the conjugate of 1 plus the square root of 5, that would be 1 minus the square root of 5. So basically the idea is on the bottom you want to get a difference of 2 squares. And that would get rid of the square root, so you multiply it by the conjugate. So if you have 1 plus the square root of 5, the conjugate is 1 minus the square root of 5. Now if this were 1 minus the square root of 5, the conjugate would be 1 plus the square root of 5. So let's go ahead and multiply it by the conjugate here. You have to multiply both numerator and denominator by the conjugate. Alright. So we're doing that now. In the numerator, you have 1 times the quantity of 1 minus the square root of 5. Well, you'll get 1 minus the square root of 5 in the numerator. The denominator is where it gets interesting. 1 times 1, well, that's 1. Then square root of 5 times negative square root of 5, well, that'd be minus 5. Which means this is going to equal 1 minus the square root of 5 over negative 4. Which now we could take that negative sign, this would turn into positive square root of 5 minus 1 all over positive 4. So the answer we're looking for here is going to be square root of 5 minus 1 all over positive 4. And I got more examples of rationalizing denominators like this. Alright, we have 1 over 2 plus the square root of 3. So we have 1 over 2 plus the square root of 3. Well, we have that radical in the denominator. You need to multiply both numerator and denominator by the conjugate to get rid of that square root. the conjugate of 2 plus the square root of 3 would be 2 minus the square root of 3. So you multiply both numerator and denominator by 2 minus the square root of 3. So if we multiply the numerator 1 times this, you would just get 2 minus the square root of 3 all over. Now, we have a difference of 2 squares in the denominator, so 2 times 2 is 4. Then square root of 3 times negative square root of 3, that'd be minus 3, which just means now you'll have 2 minus the square root of 3 over 1, or simply you would just get 2 minus the square root of 3. And that would be your answer to this problem. You would just get 2 minus the square root of 3. Alright, let's see here. 3 all over the square root of 5 minus 2. So we have 3 all over the square root of 5 minus 2. Well, it seems like this is a little bit backwards, isn't it? Before, we've seen the regular number and then the square root. Well, as it turns out, that's exactly how it's supposed to be. You see, 3 times the square root of 3 all over the square root of 5 minus 2, that's the same thing as 3 all over negative 2 plus the square root of 5. That's what you would get. You have 3 all over negative 2 plus the square root of 5. You always want to have the whole number first and then your square root second, okay? You always want to do that in the denominator. Now, we can properly multiply the numerator and denominator by the conjugate. So you have a negative 2 for your whole number expression. That part of the conjugate won't change. You'll still have negative 2, but instead of plus square root of 5, this would become minus the square root of 5 all over negative 2 minus the square root of 5. Okay. Well, let's do some distribution in the numerator. 3 times negative 2, that would be negative 6. Minus 3 times the square root of 5 would be just that. Minus 3 times the square root of 5. All over, you have now negative 2 times negative 2, that's positive 4. And then we still have a difference of 2 squares. You have square root of 5 times negative square root of 5, this would be minus 5. So you have 4 minus 5 in the denominator. This will end up being negative 6 minus 3 times the square root of 5 all over negative 1, which means you can divide everything by negative 1. You now get positive 6 plus 3 times the square root of 5. So the answer we're looking for here is going to be 6 plus 3 times the square root of 5 when you rationalize the denominator. Alright, so now we have 1 all over the square root of 7 minus 3. So yes, 1 all over the square root of 7 minus 3. This is not in standard form in the denominator. In order to make it in a standard form, we'd have to turn this into 1 all over negative 3 plus the square root of 7. Now it's in standard form. We have 1 all over negative 3 plus the square root of 7. Now we can go ahead and multiply numerator and denominator by the conjugate, which would end up being negative 3 minus the square root of 7. For both of these, the numerator and denominator. So now, let's see, if we take 1 times the numerator, you'll end up indeed having negative 3 minus the square root of 7 in the numerator. All over, let's see, negative 3 times negative 3, that's positive 9. Then you have square root of 7 times negative square root of 7, that'd be minus 7. So now all we can do is just simplify the denominator. You'll have negative 3 minus the square root of 7 all over 2, and there's no way to simplify this any further. So the answer you should get is negative 3 minus the square root of 7 all over 2. So yes, these can turn into quite a doozy real quick. These types of problems are usually not real fun to try to rationalize, but it's got to be taught. Alright, 1 plus the square root of 7 all over 2 minus the square root of 7. Uh-oh, we have radicals in both the numerator and the denominator now. It's not so simple, is it? Well, the idea is still the same. The denominator is in standard form, so this works. This will be 2 minus the square root of 7, so the conjugate you're going to multiply is 2 plus the square root of 7. So you're going to go ahead and multiply both numerator and denominator by 2 plus the square root of 7. Which now we need to FOIL the top. So 1 times 2, well, that's going to be 2. Then you have 1 times the square root of 7, that'd be plus the square root of 7. Then you have square root of 7 times 2, this would be plus 2 times the square root of 7. Then you have square root of 7 times square root of 7, this would be plus 7. You would have all that all over the bottom, which is a difference of 2 squares. So let's see, 2 times 2 is 4. Then negative square root of 7 times square root of 7, that would be minus 7. So let's simplify this further now. 2 plus 7 is what? That's going to be 9. Square root of 7 plus 2 times the square root of 7, that'd be plus 3 times the square root of 7. All over 4 minus negative 7, that'd be all over negative 3. Well, do we notice here that both the 9 and the 3 times the square root of 7 both have a common factor of 3? So we can divide both of the terms of the numerator by negative 3. If we do that, 9 divided by negative 3, that's going to be negative 3. Then plus 3 times the square root of 7 divided by negative 3, that'd be minus the square root of 7. And then the denominator goes away because you divide it by negative 3. So the answer you really should get for this would be negative 3 minus the square root of 7. That would be the answer you get. Okay, do a few more here. We have 4 plus the square root of 5 all over 3 minus the square root of 5. So now we're given 4 plus the square root of 5 all over 3 minus the square root of 5. Well, you're still going to have to multiply the numerator and denominator by the conjugate of the denominator in order to get rid of the square root. So the conjugate of 3 minus the square root of 5 would be 3 plus the square root of 5. You'll multiply both numerator and denominator by 3 plus square root of 5. Okay, so now in the top we have to FOIL. So 4 times 3, that's 12. Then you have 4 times the square root of 5, so that'd be plus 4 times the square root of 5. Then you have square root of 5 times 3, so that'd be plus 3 times the square root of 5. Then you have square root of 5 times square root of 5, that'd be plus 5. So we FOILed the entire numerator. Now the denominator is just a difference of 2 squares, so 3 times 3 is 9. Then you have negative square root of 5 times positive square root of 5. Well, that ended up being minus 5. So let's go ahead and simplify this. Let's see, 12 plus 5 is what? 17? And then 4 times the square root of 5 plus 3 times the square root of 5. That's 7 times the square root of 5. This is going to be all over 9 minus 5, which is 4. And nothing factors out to get rid of the denominator. So the answer you're stuck with here is going to be 17 plus 7 times the square root of 5 all over 4. That would be your answer. So, if you can remember basically how to FOIL, how to deal with the difference of two squares, how to take a binomial to a second power, you got this. And then rationalizing a denominator, you just multiply both the numerator and denominator by the conjugate. That's all it's going to be. So next lesson we're going to do, what is it called? Simple radical equations, where you'll have like the square root of x equals 2. You'll have to solve problems that start out as a square root of a variable and get the value of a variable. So I hope everyone has a good night. Take care.